Hi, my name is Dane Powell, and this is Ocean Academy, an innovative learning center in Boston designed for approximately 400 students on the South End. The pedagogy is based on a constructivist approach where students teach themselves through project-based learning rather than traditional instruction. The project started from my precedent study, which had a strong influence on the design. The Diana Center, located in New York, is also an urban educational building that informed my decision to pursue a multi-story site for Boston. Initially, the building began as a more rectangular or trapezoidal form, but that evolved as I studied the site more closely. The precedent showed how shared space, circulation, and openness can become part of the learning environment. Rather than isolating classrooms, the building encourages interaction, collaboration, and movement between spaces. The idea carried directly into this project that became the key driver of how the building was organized. Site analysis revealed the area of Boston has a strong urban fabric, but this also uh, uh, but also a need for improved educational outcomes. The school in this region are struggling to meet standards which enforce the need for an innovative learning institution. The intention was for this to function as a magnet type school similar to a charter programs already successful in Boston. The neighborhood itself is highly active with a strong pedestrian movement and public transit and community activity. This made an ideal location for the learning center that connects to the broader city. In the massing study, I explored multiple options and I wanted to use the terraces to activate the roof as additional learning and outdoor spaces. Over time, this evolved into the radial stepping form. The final form does several things. It creates a strong urban edge along the side and along Harrison while stepping down toward the less dense Washington side. Most importantly, it wraps around the site to create a protected courtyard, which became the primary student entry access point. That move allows the building to engage the city while also protecting the students. The building is organized around the idea of a flexible student learning. Instead of traditional classrooms, the program is made up on learning clusters, quiet pods, and maker labs. The climate analysis showed that the building receives sunlight on multiple sides throughout the day, which is a strong advantage. This allowed for a strategy that takes advantage of solar gain in the winter while controlling heat gain in the summer. The psychrometric analysis showed that the cooling demand would be relatively limited, which informed my mechanical strategy. The structure is based on a radial grid using a steel column, a concrete column, and steel beam system. This supports the open floor plan and allows flexibility in how the spaces are used. The ground floor includes a gymnasium, auditorium, and administrative spaces. Above that, it transitioned to learning clusters on the second and third floors with maker labs and library media spaces on the upper levels. This organization supports both structured and exploratory learning. The site plan reinforces the idea of separating Harrison Avenue edge from the student-focused Washington Street access. As the design developed, additional stairways were added to resolve the egress requirements and eliminate dead-end corridors. This improved both safety and circulation throughout the building. The elevation and sections show how the building steps and how the interior spaces remain open and connected. The facade includes horizontal louvers, which provide shading in the summer while allowing solar gain in the winter. Based on the climate and psychrometric analysis, the building required limited cooling but strong heating performance. As a result, I selected a variable refrigerant flow system with a dedicated outdoor air system, DOAS. This system provides localized control throughout through ceiling cassettes and allows flexibility within the building without requiring a large duct system. Passive strategy include natural ventilation, uh, um, thermal mass, solar shading, and the louvers are designed to block summer sun while allowing winter sun to penetrate the building for heat gain. These final views show the building sits within the city and how the space feels internally. The design creates a strong urban presence while maintaining a flexible learning environment inside. The overall project evolved significantly from a simple form into a more integrated design. The president helped guide the thinking initially, but the site, program, and technical system ultimately shaped the final outcome. Thank you.